Now is a good time to talk about our first important concept in Scala, immutability. What is it and why is it important? Let's learn it from a real-world use case. I'm sure that you have a bank account and that you use that account to buy the items you need. Now let's say you bought a nice pair of shoes on sale and your merchant charged you $50 for that in the store. You feel great because the shoe otherwise would have costed you $100 on the full price. Now let's say you realized that evening that you would rather invest that money than to pay for the shoes. So you went to the store and returned the shoe. Now later that weekend you open your bank account for a regular scan to see if the financial situation is in order. What do you see here? You will see two transactions. One debit that represents your purchase and money going out of the account, and another credit transaction for the same amount representing your action to return the shoe and the refund coming to your account. And this represents the classic example of immutability in the financial world. A transaction once recorded never changes, not even a single attribute. Even though your account sum came back to the same number, it recorded both the transactions representing the action that happened. However, when working as developers and writing programs, this awareness is not there so much. How many times you have written a code like this or something similar? I'm positive we all have done that several times in different projects. Here, if you call this method multiple times with an object, the same object changes its states multiple times, and this could be an issue. And this is where immutability can help us. The immutable code is easier to reason. As we saw earlier in the bank transaction example, once the object is created with a certain state, it is guaranteed to stay the same. Such code is easier to reason and reduces the mental tax when debugging or understanding how certain piece of code works. Immutable code also helps us in avoiding accidental change that may happen if the code is called from a different context and the developer is not aware on how to use it. Such bugs are so easy to creep in when the developers only see that the method is available to call, and due to lack of documentation or curiosity, they fail to understand how it actually works. When you know that an object will not change its state, it is free to be used in a multi-threaded environment, since no race condition can occur. Algorithm working on immutable objects can therefore be parallelized across multiple processors and perform better. Alright, so now that you know what immutability is, how do we represent that in Scala? Scala provides two constructs to represent mutability and immutability using a var and a val. Let's see them in action. As we see here, we assigned number 10 to a variable using a keyword var. In the next step, we reassign number 11 to num variable, and we can confirm that now num contains the value of 11. In Scala, this is how mutability works. On the other hand, we created a variable called salary using a val keyword. Once assigned, it cannot be changed. When we try to reassign another value to salary, it gave us an error. This is how immutability works in Scala. Now, another interesting thing to note is that once you have assigned a variable yourself, Scala does not assign another variable with res letters. As we see in the output, it prints the name of the variable we chose instead of res-based variable. There are other ways Scala promotes immutability in the language, such as importing immutable collections by default for use, immutable method parameters and functions, case classes which are immutable once they are created, and many more. If you are interested, you can find the details about these topics in my Pluralsight courses on Scala. As you work with Scala, there are so many ways it encourages you to adopt immutability that it becomes a habit for you as a developer, and it's a great thing.